I'm David. I'm a member of technical staff at Anthropic and one of the co-creators of MCP. And today I'm going to talk to you about the MCP 201, a bit about the protocol in depth. And for those of you who might have used MCP so far, you probably, as most people have used it around tool calling. And so this is a bit of an introduction into a little bit of the other primitives and things you can do with MCP to build a more richer experience for users. So I hope you get a little bit out of that. So let's start. There's a few basic primitives that MCP offers that just goes beyond tool calling that hopefully in the long run also explains what some of the differences are between MCP and OpenAPI and other things. And one of the first one I want to touch on is actually one of the things I like the most out of the protocol and something that I quite frequently use myself. And that's a primitive called a prompt. And so what is a prompt? A prompt is basically something that if you write an MCP server today, you can offer a user for the application that they're using with which they integrate with your MCP server, a predefined template for AI interactions. And so what you can do with this is to have something that the user explicitly wants to add to the context, and it's not something like a tool that the model would call. And so there are two things that I feel are quite interesting that what you can do with this. The first one is if you write an MCP server, you are the one who knows the best how to use the tool, how it's intended to use. And giving users an example prompt that they can actually use is a great way for them to get started. But secondly, under the hood, prompts are nothing but code. And so they can be dynamic. They can fetch things dynamically. And what you see in this scenario here is me in zEditor using a prompt that dynamically pulls in GitHub pull request comments to tell me everything on what's wrong with my code. So I can put it into the context window and then have the model help me go fix the crap I've built. So that's one part that you can use MCP servers for. And most of the editors nowadays support this, like VS Code, that, and others support this today. And building this is exceptionally easy, actually. There is just, if you have, for example, in this case, the TypeScript SDK, it's just a function that you call and you provide two functions. One for auto-completion, because prompts can have arguments, and arguments can be auto-completed. If you look quickly here, you actually see it, where it shows all the pull requests that I have written and none others. So this is the auto-completion function, for example. And then you just provide a normal function to just generate the prompt. And it's quite easy that way in a few lines of code that honestly, Cloud Code with Cloud 4 can just generate for you in most cases. So that's really one of the first primitives that I hope some of you have not seen before, which were prompts. But then there's a second one called resources. And so resources are this idea that beyond a text snippet that the user can enter into a context window, you really do want to have something that is a bit more like a file that the application itself can decide how to deal with. And so what does this mean? So one thing you can use resources for is by providing raw data from the MCP server so that the application, be it Claude Desktop, be it VS Code, be it Claude.ai, can use it in a way they want. And that's a quite abstract way to think about this. But in practice, what does this mean? It means that the application can freely choose how to interact with this. In the following scenario, what you see, it is very much like a file. So in this scenario, we're exposing the database tables of a Postgres database, the schemas for it, as resources. And in Claude Desktop, you can add that as a file-like object and then basically tell the model that way, this is what I want to focus on. And in this scenario, we're going to use later on artifacts to create a nice visualization of the database schema here. But this is just the beginning of what you can do with this. One of the things I certainly intended this primitive to be used, is for input to retrieval augmented generation. Because what it is just a simple way for an MCP server to expose raw data to a client, and the client is completely free to do what they want to do. And it's very reasonable as a client implementer to go build embeddings and build a RAG pipeline through that. So I think resources is an interesting way that has a lot more to explore for how you interact with MCP servers that I feel is a bit underexplored. But luckily, I met Harald from VS Code today, and he mentioned that at least resources, for example, will be are I think available in VS Code very soon, if not already. And then, of course, last but not least, there's tools. I don't want to go into too much detail because hopefully if you've used MCP a little bit, you probably have written a tool. It's the one thing that is a little bit, I think that makes a lot of the magic up of MCP because it's the one thing you write it and the model invokes. So where the first two things, prompts, a user invokes, resources, the application really drives, this is something the model drives. And that's a little bit of that magic that when you write your first MCP server, you have the first tool invocation. Is quite cool because it's the first time a model does something that you personally probably care about, be it like querying your database, be it interacting with some systems in the most fun ways. I've seen some really creative ways. I've seen people use MCP tools to program their physical synthesizers, which I, as a crappy part-time musician, love. So these are the three main basic primitives that MCP offers. And these three main primitives give you a bit of a way for building more interactivity that just goes beyond tool calling. And one thing I think most people, we don't talk enough about is, if you look at these primitives, it might be like, but when do I do what? There might be a bit of an overlap. And so there's a thing that I call the MCP interaction model that is like somewhere deeply buried in the specification that basically tells you that these are meant to be across three different ways of how to interact with the MCP server. So prompts are user-driven and usually exposed in applications through @ commands or / commands, as you've seen in the Z editor. But and resources, on the other hand, are like application-driven. So the application is freely able to choose what it wants to do with it. And then tools, of course, are the ones that we're all most familiar, the models themselves deal with. And so if you think about an AI application using an LLM, and there's a user in front of it, you have all three big parts available to you, like how you interact with them. And so this gives you quite already like a slightly richer interaction pattern than if you were just using tools. But there's a bit more to that. There are more richer interactions that MCP can enable for you if you use the full richness of the protocol. And to give you a bit of a sense, I can show you a task I would want to do, like what I want to implement as an MCP server, that with the current scenario, what I've shown you so far is hard to do. And that is simply, how can an MCP server summarize a discussion from an issue tracker? So I would like to have a GitHub discussion be summarized in one way or the other. Now I have a problem, because if I want to summarize an issue from a GitHub pull request or something like that, I need access usually to a model, right, that helps me do the summarization. And so if you think about an MCP server with an MCP client and an MCP server, the MCP client is really the one who is dealing with a model, right? In this case, my Claude desktop would deal with, obviously would use Claude. And then it would connect to this issue tracker MCP server. Now, the issue tracker MCP server has two options. It can either bring its own SDK, be it like an Anthropic SDK or one of our competitors. But that gives you an awkward situation because now I need to provide an API key. But I already have like a cloud subscription or something like that. So I kind of really want to use that LLM already. And maybe, that MCP server suddenly uses a competitor model and I don't even want that, or I don't have an account there or whatnot. So what the sampling does, sampling is a way for an MCP server to go back to the client and say, hey, you have a model configured. You have maybe the user pays a subscription for your application already. Can you just give me that completion? And so reality is this thing is terribly named with sampling and highly confusing because of the name for the most part. But what you can think about it is the server requesting a completion from the client. And what does it mean for the client? The client is in full control over security, privacy, and cost at all times. You will see throughout the talk, naming was certainly not my strength in the whole protocol. So sorry for that, but well. And one of the interesting thing is we are certainly planning to bring this at least to Cloud AI and Cloud Desktop. And I know other MCP client implementers are actively working on bringing this to their clients. So it's a bit of like a restricted thing at the moment because it's not really easy to use because clients just don't support it. But I think throughout the next 1, 2, 3 months, this will be much more widely spread. And then lastly, there's another feature that's quite well known. I feel it's a bit on the niche, arcane side of things of MCP. And it's a feature called Roots. And that goes back to a terrible naming because it's very undescriptive of what it does. But let's imagine, and it's actually one of the first things I wanted to do because I've done work on source control systems forever. And despite having literally actively worked on these things for 15 years, I cannot, for the sake of God, remember any fucking Git command. So I want to have, and models are way smarter than me doing that. And so I would love to have a Git server that just takes care of my repository for me. But now I have a problem, right? I have an application running locally, that's the MCP server. And how does it know where's the repository I deeply care about? The client on the other hand side, be it Z, be it VS Code, be it any IDE I've opened, knows what I've opened, right? It's obviously I have workspaces open. And so Roots are initially designed to ask a server from the MCP server, ask the client, hey, can you tell me what are the workspaces? What are the roots that I should care about? And the client in this scenario would say, hey, you have the Python SDK open, this is the path, and now I can have the Git server operate on that. But why is it not called workspaces? It's not called workspaces because this feature is not just local. It's technically can be, a way to restrict an MCP server to any kind of URI. So if you had, for example, a hypothetical Notion server, you could say, I only want to work on this part of my Notion knowledge base or something like that. And so it's a way to restrict the client at a server to a subpart of the system in general. And so there's a lot of ways we can still explore this part. And so this is, for example, something that some of the IDEs currently already support. And I think it's something that people miss when they implement things, when they want to build something a bit more richer. So we have these three major, these now 5 primitives. There's these 3 basic primitives, prompts, resources, and tools that give us a good interaction model. Then we have some of these 2 additional richer ones. There's way more to the protocol that I don't have the time to go in, like notification about progress. There's cancellation and tons of other things that really make for a more interesting experience. But let's just take those 5 we have and put them all together to build an MCP server that goes beyond the standard tool calling servers that we see together today. And so let's build a hypothetical server that deals with for example, a chat backend, be it Slack, be it Discord. For a steering committee, we use a lot of Discord, so maybe I want an MCP server that talks to Discord and helps me, summarize and interact with it through an LLM. And so I can use first and foremost prompts to really build an example and say hey, can you summarize a discussion for me? And I can provide this as a prompt to the user so that I don't have to type this every time. And I have a shortcut basically to do that. And I might even want to autocomplete most recent threads in the chat application. And so it's a really nice way for me to get started in the morning. And I'll say, can you just summarize this discussion around authorization? Because they have, I have forgotten what they have done in the last 3 days or whatnot. And here's something what I actually do. I do this nearly every day. I go one of our internal connectors that connects to our internal Slack and go hey, what's new? What happened since yesterday? I'm London-based. San Francisco went all crazy overnight. I have 1,000 notifications, and I don't want to read them. I want Claude to read them. So I just have a prompt say, hey, what's new in MCP land? And then you can have as resources the list of channel, the recent threads, things like that you might want to, an application might want to do embeddings about or whatnot. And I can do these things at the same time. I can expose something, data as a prompt, and I can expose it as a resource at the same time. There's no real limitation and why I would not expose the same data in two different ways. Then, of course, lastly, I do have my tools. I have my search. I have my read channels, my read threads. And of course, I can have summarization via sampling. And putting these three things together with prompts, research, and tools and using sampling for summarization, I already get a much richer experience that I would otherwise get if I have only a tool calling MCP server and I need to wait for the model to go and call my tool and spend the tokens and so on. And so hopefully I showed you a little bit more about like that, what MCP can do if you were using it to its full extent and find a client that supports it to its full extent. But then I think we're at the moment at like at a spot in time where I think it gets very interesting for MCP. For the community of the last 6 months has done really an amazing job. They have built like 10,000 MCP servers, tons of clients, but they have built them locally because that's what MCP was about. Like download a Docker container, run it locally. And that's all great and fun, unless I want to like maybe connect to my payment provider and I don't want to download a random third-party MCP server and give them my credit card information or whatnot, or deal with like my online accounts. And so I think there's a really big moment at the moment for MCP where I think we can get it to the next level by moving it into the web. And so with Claude AI integrations that we launched earlier this month and other clients following as well, we are getting to a scenario where MCP servers are not just my local process, a local Docker container, but a website, like a URL somewhere, not a website, but like an MCP server that's hosted on the internet. And so instead of having to download my weird third-party payments server, I can put in the MCP server URL for the payment provider of my choice. And I know it's the payment provider. I know that that's where my online account is, what I can do. And I think that's a great next step to really enable to make MCP ubiquitous everywhere and like be a true standard for LLM integrations. And for that, we need two things. And I don't want to get into too much details because we have people later on like Aaron and others who are way better versed in talking about authorization than I am. But there are these two key pieces that need to fall in place to make MCP really, truly like not just something that works locally, but a web standard. And that is authorization that is scaling. And so what authorization allows you to do is like if you have finally like a MCP server that's hosted on the internet, now you can offer people to log into that, and they can finally connect their online accounts in ways that is currently much more awkward to do. And you can go to your payment provider, log in with the online account, you trust that website, and now that MCP server that they provide has access to the payment data that you have, and you can trust this whole thing. And suddenly, if you really think about what this enables when you can, in a trusted way, connect MCP servers to already existing online accounts, what it really just means in the end of the day is we can move all these interactions humans currently have by clicking around on websites, and we can have them through LLMs instead. And I think that's a great opportunity to build something, where you get up in the morning, you're just like, what happened? Can you tell me like what are my priorities today? And then Claude or whatever would like go and connect to your issue tracker, read your emails, and tells you what to do, and maybe even orchestrate some of the actions under the hood. And I think this is a truly interesting and new way for MCP. There's two main modes that this works. There's the one that I just described, the web mode. You connect to an online account, and that's kind of cool and quite nice and offers this like new web, like MCP as a web moment. But then, of course, and Aaron will talk probably way more about this because he understands this better than I do, is enterprise. And so what does this mean is, in the current way authorization is specified and implemented in MCP, is what you can do is you can deploy internally in your company MCP servers on like internal available services. And you can control as a developer the deployment, you can control the feature set, you can roll out new things without having to upgrade everybody by itself because it's just a website basically. But then you can still use your central identity provider be it Okta, be it Azure ID, or whatever you might want to use. And I've seen this to great effect. I've seen some companies build this out where in the morning you log in once with your SSO, you go to your LLM chat interface of your choice, you click 5 MCP servers, and behind the back, the MCP servers will check the tokens, will talk to the identity provider, exchange the token using token exchange for a for a token for the backend. And what the user sees is just click 5 things, and suddenly they have access to their accounting data in the company, to their issue trackers, and so on and so forth. So I think this is a really, really interesting moment that for enterprises make MCP way more usable and way more manageable. But then there's a second part of that is when you have a lot of MCP servers on the web, you kind of want to scale them. And MCP clearly is not REST. And there are reasons for that we can probably have to discuss all day long. But we have something built now into the protocol called Streamable HTTP that is basically rolling out to all clients at the moment, that's nearly available in all SDKs. And what it does, it basically allows you to scale MCP servers similar to normal APIs. And so it boils down to 2 very simple ideas. The first one is, as an MCP server author, you can choose to just get a request and return a result. Okay, that looks like REST. It's slightly different, but it's basically the same. And that makes it very easily scalable. It means you can put it into a Lambda function or wherever you want, and you can just scale it via whatever, these kind of like scaling mechanics on the web you have, right? And then second, if you want a bit more richer interface, if you want to send notifications, if you need to ask the client for sampling, you can open a stream, an SSE stream, so we're just back to normal web technology, things that firewalls and others understand really well. And you just send notifications, you send sampling requests, and then eventually you send the result. Why do we do it that way? Because servers otherwise don't have a way to potentially connect to a client. Servers cannot initiate a connection to a client. You're on your laptop, you're talking to something, they can't talk to your laptop back. So this is a way for servers to provide requests to the client while the client is responsible for the connection. So I hope with that, I was able to give you a bit of an overview, I think, about what's possible at the moment with MCP. And I think throughout the day, you will see way, way more about this. Jerome later will talk a bit about some of the more exciting things that are coming up in the future from the project side of things. And then we have lots of people talking about authorization and fun new ways for how you can use MCP servers. But I just want to very, very quickly talk about 2 or 3 things I'm really excited about what comes next for the project and the protocol. The first one is in 2025, you cannot have a presentation. I nearly got through it without the word agents on it. So there we go. I do think that agents are an exceptionally interesting proposition that I think we're all actively already building. We actually even might use MCP in ways, but they are semantics that I think can improve the whole interaction around agents. And so we will very strongly talk and think about around asynchronous task execution. So tasks that don't execute in a day, in a few seconds, but execute within an hour, execute within a day. We have other aspects sometimes you want to be very explicit as an agent to elicitate feedback from the user. Do you really want to do this? Or you might need to agree to the terms of services because legal always finds its way into computing somewhere or the other. And so we're going to work on elicitation, which is something that's currently very much discussed in the committee and something in the MCP team at Anthropic and something that we probably put into the protocol very, very soon. And then we're working towards an official registry API because at the moment there's tons of registries. We really want to have a central place where you can discover and publish MCP servers to. And that then enables, because we will make this all open source, enable people to build something that is equivalent, but better for enterprise use that adds that adds trust things that a specific enterprise cares about. And so we want to just build the basic public registry and allow people to build on top of that whatever they feel they need. And of course, I think there's additional facilities in multimodality, like streaming and other things that I find very, very interesting. And that's just the protocol side. On the ecosystem, a time. We have more to come. There's a Ruby SDK coming. Google is working on a Go SDK. So we see just more and more things that will help you to build MCP servers. And with that, I'm very much told I'm probably past time. So thank you so much. You will find me in the hallway. So if you have any questions around MCP, thank you so much.